these last two antiderivatives have exponentials. So we have one base e and base 2. And so we can quickly review. I'm going to go down to the bottom of the page and review the property of exponentials when we talk about U-sub. So we'll squeeze it in at the bottom down here. We'll actually have a lot of space because exponentials are the shortest ones to have to do. So we want to remember that U is the exponent. In an exponential U-sub problem, it's going to be U is the exponent. Unless it's within a quotient rule, then that rules, and it's always the denominator. We already talked about that. But otherwise, U is going to be the exponent in an exponential. And we basically have two cases. We either are going to end up with an e to the U, which is going to integrate like e to the x did, or we're going to have a number to a U. So we'll say 3 to the x dx. So what was the antiderivative of e to the x? That was just e to the x plus c. So antiderivative of e to the u is going to be e to the u plus k. Antiderivative of 3 to the x would be 3 to the x over ln of 3. So when we sub in, it would be 3 to the u over ln of 3. So you have two cases, and we're going to remember u is the exponent. So these are kind of like the weirdest ones. Product and quotient are pretty similar. These are not very similar to those substitutions, but at least we have some rules to follow, which you can pause and write down if you need a little bit more time. But I'm going to go back up here, and I am going to look at this first exponential. So u is going to be the exponent. So I have x squared plus 1 times e to the 2x cubed plus 6x. So u is going to be the exponent. That's what's getting manipulated. We're raising it from base e, so it completely changes the number it was. So u is going to be 2x cubed plus 6x. The derivative of that is going to be 6x squared plus 6. And we need to multiply by dx. So u is always what's getting manipulated. This is just a different type of manipulation, but you could take any number. Say you have 5, plug into your calculator e to the 5, and it will definitely not come out to be 5 again. It changes it, manipulates it. So after I figure out my u and my du, I'm ready for the super difficult substitution. I want to make it either an e to the u or 3 to the u, like we talked at the bottom. E to a power or number to a power. So this one is base e. My u is up as the exponent, so this is going to sub in as e to the u, which is perfect because that's a nice antiderivative. I don't even have to add 1. That's all e to the u. After you think about what's happening to u, you think about du. So I'm going to switch colors here and make sure I have a perfect du. So I need a 6x squared plus 6 dx. I have an x squared plus 1 dx, so the dx is good. But I need to make this x squared a 6x squared and this 1 a 6. So I need to multiply by 6 on the inside. That would make it 6x squared plus 6, which is perfect. That's exactly what I need. But if I want to put a 6 on the inside, I have to put a 1 6 outside to balance it. We're not going to make it 6 times too big. So as long as the 1 6 is outside, I get to write my perfect du. So I've got my notation all good, and now I'm ready to integrate. I'm going to keep the 1 6. The antiderivative of e to the x is e to the x. The antiderivative of e to the t would be e to the t. So the antiderivative of e to the u would just be e to the u. And I need my plus k. Last step after you integrate is to sub back in for x's. So 1 6 e to my u was this 2x cubed plus 6x. And then I have a plus c at the end. There is my first exponential one. See if you can start the next one before you watch the video.